This will be the 18th session on relative velocity. So today we will take up the calculation of relative velocity between 2 points. We are given 2 moving points with respect to some frame f, and we have to determine the magnitude and direction of relative velocity of one point with respect to other in some given frame f. So in 13th video it was relative velocity between 2 points was defined, and I just stated here because in 13th video it was already discussed fully. So suppose we have the frame f is some reference frame, P1 and P2 are 2 moving points. R is the relative vector of P2 with respect to P1 in frame f at time t. So not frame f, relative vector of P2 with respect to P1 at time t. Velocity of P1 with respect to frame f is v1f, and velocity of P2 with respect to frame f is v2f. Then we have discussed in the 13th video that relative velocity of P2 with respect to P1 in frame f is defined to be v2f minus v1f. v2f and v1f are the respective velocities of P2 and P1 with respect to f at some time t, and that was shown to be equal to dr by dt in frame f. In fact, that was the definition of relative velocity between 2 points in frame f. So this was fully discussed in the 13th video. Okay. Also in the links description box, the links of all the previous relative velocity videos will be uploaded. Okay. So you can refer to those links and access those videos directly. So now what we have to do that one thing I would like to say that whatever problem we'll take up today, that f will be taken to be the ground frame. F will be assumed to be the ground frame. Okay. So P1 and P2 are 2 moving points with respect to ground frame, and we have to determine the magnitude and relative velocity of P2 and with respect to P1 and P1 with respect to P2. Okay, so one more thing I would like to say. Relative velocity of P2 with respect to P1 in frame f is v2f minus v1f. So relative velocity of P1 with respect to P2 in frame f will be v1f minus v2f. And you can say this will be just the negative of this quantity, minus v p2 p1 f. So this means relative velocity of P1 with respect to P2 in frame f at time t is negative of the relative velocity of P2 with respect to P1 in frame f at time t. That is, these two relative velocities will have the same magnitude but opposite directions. This means that suppose P1 says that P2 is moving rightward at 10 meter per second, then P2 will observe that at that instant P1 is moving leftward at 10 meter per second. So relative speed of P2 with respect to P1 in frame f and relative speed of P1 with respect to P2 in frame f, they are both equal in magnitude but opposite in direction. Fine. Okay. So today what we'll take up is, we are given 2 points P1 and P2. They are moving with respect to ground frame, and we have to determine the magnitude and direction of relative velocity of one of the points with respect to other. Okay. So for that we'll take up the discussion in 2 phases. We'll take up the discussion in 2 phase discussion we'll carry out. So phase 1 will be this. Phase 1 will be this. Phase 1, in this case, phase 1 will assume that velocities of P1 and P2 with respect to ground are either parallel or anti-parallel. Okay, that will be phase 1. And phase 2 will be that the velocity directions of these 2 points are neither parallel nor anti-parallel. Okay, they make some other angles. Okay, so these 2 phases will take up. So first we'll discuss phase 1. Phase 1, we assume that V1G and V2G. Here G means ground and 1 means P1 and 2 means P2. In phase 1, V1G and V2G are parallel. This means parallel or anti-parallel. Okay, this is phase 1. So V1G and V2G are parallel or what? Anti-parallel. This is phase 1. Okay, and phase 2 is that direction of V1, Vg and V2g are neither parallel nor anti-parallel, they are some other directions. V1g and V2g are neither parallel nor anti-parallel. Okay. V1g and V2g are neither parallel nor anti-parallel. Okay. So we'll take these two phases. First we'll discuss phase 1. Alright. Now I'll wrap this. Okay. So in this video 18th session we'll discuss phase 1 first. Okay. If time permits we'll discuss phase 2. Otherwise we'll put phase 2 in the 19th video. Right. As I've told in the first video of relative velocity, we'll carry out a complete exhaustive discussion on relative velocity, starting from basics up to direct advanced JEE advanced level. So if you go through all these videos properly, your preparation for board, for mains and advanced, all will be completed, for NEET also. You don't have to refer to any other book, nothing. You don't have to see any other book at all. This will be a complete exhaustive discussion on the chapter on relative velocity. If you carefully go through all of these videos, then I can guarantee that you will solve most of the problems which come in the competitive exams, either JEE, mains or advanced or NEET. Okay, so it's a complete exhaustive discussion, nothing has been left out. Fine. So now we'll take up problems on phase 1 first. Alright, I've done this. Okay. So phase 1. Phase 1, okay. So before you go to phase 1 more thing I'd like to say, that when we talk of relative velocity between 2 points, say Vp to P1f. So Vp to P1f is nothing but V2f minus V1f. This is a general discussion, it has nothing to do with phase 1 or phase 2. General definition of relative velocity. V2f minus V1f. This can be written as V2f plus minus of V1f. This is the definition of relative velocity between two moving points. You know from the theory of vector that minus V1f is nothing but the reverse of V1f. Reverse of V1f meaning vector whose magnitude is same as that of V1f but whose direction is opposite to V1f. So this is a general meaning of relative velocity between 2 points. If you have to find the relative velocity of P2 with respect to P1 in frame F, then we reverse the velocity V1f and vectorially add it to V2f. Okay. If we have to find the relative velocity of P1 with respect to P2 in frame F, we reverse the velocity of P2 with respect to F and add it vectorially to V1f. So, if you have to find the relative velocity of P2 with respect to P1, so reverse the velocity of P1 with respect to F and add it vectorially to V2f. So this is the basic rule you must always remember. Okay. So if you have to find Vp to P1f, this means we reverse the velocity of P1 with respect to F, that is we take minus V1f and add it vectorially to V2f. Alright. So now we take up the problem on phase 1. So this concept is a general discussion, general concept of relative velocity between 2 points. It has nothing to do with phase 1 or phase 2. It is valid in both the phases. In both the phases it is going to be valid. Okay. So now we take up those problems on phase 1. Okay. And one more thing I'd like to say before going to phase 1. See, once you have reversed it, V1f, that is minus V1f, then the rule for finding Vp to P1f is just the usual rule for vector addition. As you add two vectors, you have to add this vector and this vector. That's all. Okay. Once reversing, after you have reversed V1f, you have to just follow the rules of vector addition to get V2f. Alright. So, phase 1, we take up the problems on phase 1. Okay. We take up the problems on phase 1. Okay. So, phase 1 I have just mentioned just now. V1G and V2G are parallel or anti-parallel. Okay. So now before going to, so I'll write it here. I'll write it down. Okay. Vp2 P1. Instead of F, we are taking ground frame. Okay. But the basic concept is valid for any other frame. Suppose instead of ground frame it is M frame, then we'll take V2M minus V1M. But just for the sake of understanding, for the sake of practice, we are, instead of F we are taking ground frame. But the same theory, same method and same theory will apply if we take some other reference frame. Then also the same method will also apply. Okay. So Vp2 P1G is nothing but V2G and V1G. V2G minus V1G, which can be written as V2G plus minus V1G. As I've discussed just now, this is just the reverse of V1G. So we add this vector to V2G, we get the relative velocity of P2 with respect to P1 in ground frame. Okay. So now before going ahead in phase 1, one more thing I would like to say, whether it's phase 1 or phase 2, basic method of relative velocity calculation remains the same. But in view of its importance, I have split this relative velocity calculation between 2 points in 2 phases, phase 1 and phase 2. Okay. So phase 1 is also very important. You must be totally conversant and totally thorough with this concept, because this concept can be applied anywhere. It might come in mechanics or even in other branches also. Electrodynamics, thermodynamics, optics, moving mirrors, moving lenses, moving sources. There also relative velocity concept applies equally important way. Okay. So before I go ahead, one thing I would like to say, suppose we have two vectors A1 and A2 of same type. We add them, we get the resultant vector A3. Alright. So now one thing I would like to say regarding vector addition, that two special cases arise. Suppose A1 and A2 have the same direction. Okay. A1 and A2 have the same direction. And second is A1 and A2 have opposite directions. And A3 is the vector sum of A1 and A2. So it is the resultant of A1 and A2. Fine. So see, this is the first case. Phase 1, case 1, phase 2, case 2. See, first thing, if A1 A2 suppose have same direction, in that case, A3 magnitude of vector A3 will just be equal to A1 plus A2. And direction of A3 will be same as that of A1 or A2. Is parallel or anti-parallel to A2. ठीक है? Okay. Sorry. A3 is parallel, not anti-parallel. Sorry. Parallel to A1 or A2. So A1 A2 have the same direction. Then the magnitude of vector A3 will be the sum of magnitudes of vector A1 and A2, and its direction will be same as that of A1 or A2. So this result must be remembered while calculating the relative velocities. Okay. So for example, I take an example. Suppose magnitude of vector A1 is 4 units and it has the rightward direction. This arrow means rightward direction and this 4 means magnitude of vector A1. And suppose magnitude of vector A2 is 8 units and this also has the rightward direction. So in this case, A3, which is the vector sum of A1 and A2, magnitude of A3 will just be equal to the sum of magnitudes of A1 and A2. That will be 4 plus 8, yani 12 units. And direction of A3 will be same as that of A1 or A2. So in this case, direction of A3 will be rightward, same as the direction of A1 or A2. This point should be kept in mind. Okay. So in phase 1, this was the first point to be taken into account, which I have told you. Then in phase 1, the second point, A1 and A2 have opposite directions. Now I'll rub it, okay? Now, phase 1, case 2 we take, A1 and A2 have opposite directions. See, this concept I am just refreshing It is the concept of vectors, but this should be kept in mind because I've seen many students doing mistake in finding the relative velocity between 2 points when their velocities are parallel or anti-parallel. I've seen many mistakes committed by the students. That's why I am refreshing this concept of vector addition here, okay? And phase 2 is again, suppose A3 is equal to A1 plus A2. And suppose A1 A2 do not have they have opposite directions. A1 and A2 have opposite directions. For example, suppose that vector A1 has a magnitude of say 10 units and it has a rightward direction. This arrow, rightward arrow, means rightward direction of vector A1. And suppose vector A2 has a magnitude of say some magnitude, say that is in leftward direction, okay? And suppose magnitude of vector A2 is say some real number lambda. This is the magnitude of vector A2. It has a leftward direction. And where magnitude of vector A1 is 10 in rightward direction. Okay. So now in this case, A3 is the vector sum of these two vectors. So A3 is the resultant of vector A1 and A2. In this case, magnitude of vector A3 will be difference in magnitudes. Magnitude of difference in magnitudes, 10 minus lambda. A3 will be written as mod of 10 minus lambda. The lambda is the magnitude of vector A2. Okay. Then is just for example, I'm just explaining the meaning. Okay. Or I'll take it this way. Okay. Just wait. I'll take it this way. I'll just rub it. Okay. Suppose a vector A1 has a magnitude A1 in rightward direction and vector A2 has a magnitude A2 in leftward direction. I'll rub that data. Okay. And now A3 is the vector sum of A1 and A2. Then from the parallelogram law of vector addition, magnitude of vector A3 will be magnitude of the difference in magnitudes of these two vectors. Is it clear? Magnitude of vector A3 is equal to magnitude of the difference in magnitudes of two vectors. And direction of A3 will depend on the direction of A1 and A2 and which one is greater among A1 and A2. So for example, see, if A1 is more than A2, magnitude of vector A1 is greater than that of A2. In that case, magnitude of vector A3 will just be equal to A1 minus A2. And its direction will be same as that of the vector having greater magnitude among vector A1 and A2. So in this case, A1 is more than A2. So direction of A3 will be same as that of the vector A1. But A1 has a rightward direction, so A3 also will have a rightward direction. And second case, if A1 is less than A2, again in this data, then A3 will just be equal to A2 minus A1. And its magnitude of vector A3 will be same as that of the vector of greater magnitude among these two vectors. Here A2 is more and A2 has a leftward direction. So A3 will also have a leftward direction. To this point I think it is clear to you. Okay. So if two vectors are being added, they have the same, they have opposite directions. And A3 is the resultant of their vectors. Magnitude of vector A3 will be equal to this much. And its direction will depend on that amongst vector A1 and A2 which is of greater magnitude. The one having greater magnitude will also be the direction of vector A3. So if A1 is greater than A2, the direction of A3 will be the same as A1. And if A2 is more than A1, the direction of A3 will be the same as that of vector A2. Okay, and its magnitude will be written in this way or this way. Fine. This thing I have cleared it. It should be kept in mind. Okay, fine. Now I'll rub this. Okay. So now I'll take up some examples on phase 1. Fine. I'll take up some examples on phase 1. Some examples on phase 1 I'll take up. Examples on phase 1. Fine. So, examples on phase 1. Examples on phase 1. Phase 1 we take up some examples on phase 1. Fine. So, In phase 1 we assume that velocities of P1 and P2 with respect to ground are either parallel or anti-parallel. Okay. So in each of the, we take some numerical examples. In each of the numerical examples, what we have to do is that we have to find the relative velocity of P2 with respect to P1 in ground frame, and also the magnitude of direction of this relative velocity. So we write down the vector relation V P2 P1G, that is same as V2G minus V1G. Fine. Vp2 P1 slash G will be written as V2G minus V1G. And this I mentioned just now. V2G plus reverse of V1G. V2G plus reverse of क्या? V1G. Fine. Alright. चलिए. Phase 1. Okay. Fine. So now see. We take up some examples. So in each of the given cases, find the magnitude and direction of Vp2P1G. G means ground frame. Vp2P1G meaning is clear, which I have stated just now many times. So now one thing, I'll just suppress this G. I'll not write G. G is implied. Okay. I'll just write it as Vp2P1. That's all. Just to simplify the notation, since I've already made it clear here, Vp2P1G will just be denoted by Vp2P1. Okay. That will just be denoted by what? Vp2P1. Fine. So each of the given cases we have to find this magnitude and direction of Vp2P1. Okay. So first example. First example is this. This is P1. Okay. I assume that P1 and P2 are moving along line joining them, but that is not necessary. They can be situated anywhere. But just for the sake of illustration, I'm just assume that P1 and P2 are moving along line joining them in either same direction or opposite direction with respect to ground. But that condition is not necessary. Okay. So now first example is this. Velocity of P1 with respect to ground is say 10 meter per second. Okay. And velocity of P2 with respect to ground at that same instant is also in same direction as this. But it has a magnitude of say 15 meter per second. Both velocities are with respect to ground. Now we have to tell what is the velocity of P2 with respect to P1 in ground frame. Relative velocity. So this theory will be applied here. So Vp2P1, I am not writing G here, just I have mentioned it just now. This is just equal to V2 and minus V1. Reverse of V1 and vector sum of reverse of V1 and V2. So now you can say V2 is this 15 right, okay? 15 meter per second towards right. I just write the 15 and right. I won't write meter per second. I'll just write 15 rightward, okay? And now V1 is 10 right. So reverse of V1, that is minus V1, will be 10 left. Fine. So minus V1 is nothing but 10 left, 10 meter per second left. And V2 is nothing but 15 right. Now we have to add these two vectors. Now you can see these two vectors have the same, they have the opposite directions. And their magnitude, one is 15, one is 10. So now we have, just now as I discussed, on the theory of addition of two vectors in opposite direction. That theory applies here. So Vp2P1 is the resultant of these two vectors. That is the resultant of these two vectors. This means Vp2P1, magnitude of this will be same as the magnitude of the vector sum of these two vectors, and they are in opposite direction. So magnitude of this will be equal to 15 minus 10, 5 meter per second, and greater one is this one. This is the vector of greater magnitude, 15. 15 is more than 10. This is rightward direction. So this also will have a rightward direction. So one answer has been fully obtained. I hope you understand it now. So see, one thing repeatedly I'm telling, once you have reversed V1, then you have to follow the usual rules of vector addition. Okay. So one thing I'd like to say. I have seen, suppose in this case we found V2 and minus V1. I have seen many students doing in this way. To find Vp2P1, what do? They write in this way. 15 minus, and then they write minus 10 plus 10, all sort of things. No, don't do that. Or that, I would not like you to proceed in that way. Unnecessary, I don't want to fiddle with mathematics. Okay, I've seen many students writing in this way. 15 minus 10 and then they say 5. No, don't say this. No, not like that. Suppose 15 is leftward and 10 is rightward, then as they find the relative velocity, students write 10 minus 15. No, not like that. No, I would not recommend you to do that way. You can directly reverse and add, that's all. Once you reverse and then follow the rules of vector addition. As simple as that. Fine. So in this case we do this way. You have to find P2 with respect to P1. We reverse this and add it vectorially to 15. Now this V1 is 10 right. So if we reverse it will be 10 left. Now we have to add 15. We have to add 15 right and 10 left. Now we have to follow the usual rules of vector addition. So once we have reversed it, we just have to follow the rules of vector addition. That's all. Now we have to add these two vectors. They have the opposite direction. The magnitude of the resultant will be 15 minus 10, 5. And this has a greater magnitude. This is rightward direction. So relative velocity also will be in same direction as the vector of greater magnitude. That is rightward. Fine. So in first case, Vp2 P1 is 5 meter per second in rightward direction. Okay. So the first example I have discussed. Now I take another example. So see, I am mentioning it again. I think I have not counted. I have not done any counting. But I think I will make around 100 to 125 videos on relative velocity. I am telling you. You will see in the coming videos, there will be around 125 videos on relative velocity. And how many videos on Newton's laws I can't tell just now. I myself can't count. Okay. Now second example we take in this way. Suppose P1 is this. P1 is having a velocity of say 10 meter per second with respect to ground in rightward direction. Here P2 is situated. P2 is also moving with respect to ground in same direction as P1, but its speed is less than that of 10. Suppose its speed is say 7 meter per second with respect to ground, speed of P2. Okay. The speed of P2 with respect to ground is 7 meter per second in rightward direction. Now again we have to find the velocity relative speed of P2 with respect to P1 in ground frame. Okay. So I write the vector equation Vp2 P1. I am not writing G. G is implied. So that will just be equal to V2 minus V1. V2 is the velocity of P2, this one 7 right. V1 is the velocity of P1, 10 right. So this will be V2 plus reverse of V1. Okay. Now you can see V2 is what? 7 right. Velocity of P2 with respect to ground, that is 7 right. And velocity of P1 is what? 10 right. So minus V1 will be what? 10 left. Is it clear? V1 is the velocity of P1 with respect to ground, that is 10 right. So minus V1 will be 10 left. So relative velocity of P2 with respect to P1 is the vector sum of what? 7 right and 10 left. Velocity of P2 with respect to P1 is the vector sum of 7 right and 10 left. Now these two have opposite directions. So magnitude of Vp2 P1 will just be the difference in magnitudes of these two vectors. 10 minus 7, 3 units. In this case it will be 3 meter per second. And its direction will be same as the vector among these two vectors which has greater magnitude. 10 is more than 7. So direction of this will be the direction of Vp2 P1. So direction of Vp2 P1 in this case will be 3 left. So 3 meter per second towards left is the required answer. I hope you have understood what I have said. Fine. So in this case we see that Vp2 P1 will be 3 meter per second towards left. Fine. So second example I have discussed. Okay. I'm rubbing it. Okay. So I can't count. I haven't counted yet. But I don't think there will be anything less than 125 videos on relative velocity. I am telling you repeatedly. And as far as Newton's laws are concerned, I don't know myself. Whether it will be 200 videos or 300 videos, I don't know. Only when I make the videos, I will see. I don't myself have not counted. Okay. Now we take third example on phase 1. On phase 1, we take up the third example. Fine. So third example is this. This is P1. This is P2. Fine. Now, P1 is this. P1 is say 12 meter per second. Okay, fine. And P2 is say 8 meter per second. Both are with respect to ground. Both are velocities with respect to ground, and we have to find the relative velocity of P2 with respect to P1 in ground frame. Fine. So V P2 P1 is nothing but V2 minus V1. V2 is the velocity of P2, 8 left, and V1 is the velocity of P1, 12 right. That is same as V2 plus reverse of V1, that is minus V1. Okay. Now V2 is nothing but velocity of P2 with respect to ground, that is 8 left. And minus V1 is nothing but the velocity of reverse of velocity of P1 with respect to ground. Now velocity of P1 with respect to ground is 12 right. So minus V1 will be 12 left. So this is 12 left. Now we have to add these two vectors in usual way. Now they have opposite directions. Now they have the same direction. See, both are leftward. So relative velocity between these 2 points will have a magnitude equal to 8 plus 12, 20 units. In this case 20 meter per second. And they have the same direction. So Vp2 P1 also have the same direction as these two. So it will have a leftward direction in this case. So in this case, the answer also we have obtained. Fine. So Vp2 P1 will be written as 20 meter per second towards left. Okay. So third example also I have discussed. Fine. Now I'll rub this. Okay. Now I take up the fourth example. Now fourth example is this. P1 is moving leftward at say 10 meter per second. Okay. And P2 is moving say leftward at say 22 meter per second. Both the velocities are with respect to ground. Now again we have to find the velocity of P2 with respect to P1 in ground frame. Okay. So velocity of P2 with respect to P1 in ground frame, I simply write Vp2 P1. Okay. This will be equal to V2 minus V1. That is nothing but V2 plus minus of V1. Okay. Now see, V2 is what? 22 left. This will be 22 meter per second towards left. I write simply as 22 left. And V1 is what? 10 left. So minus V1 will be 10 right. 10 meter per second right. Now we have to add these two vectors. And the resultant of these two vectors is Vp2 P1. So Vp2 P1 will now the vectors of these two vectors, they have opposite directions. So magnitude of Vp2 P1, that is relative speed of P2 with respect to P1, will be 22 minus 10. As per the law of parallelogram, law of vector addition, which I have stated just now, that just be equal to 12 meter per second. And direction of Vp2 P1 is same as the direction of the vector among these two vectors, which has larger magnitude. Larger magnitude is this one. So Vp2 P1 also have a leftward direction. So direction will be towards left. This is the required answer. I hope it is clear. So velocity of P2 with respect to P1 will be 12 meter per second towards left. Fine. See, one thing I'll tell. These concepts are extremely important. They are, especially in optics, geometrical optics. Here we have a moving plane mirror, moving source. Find the velocity of image. A moving concave mirror, moving convex mirror, moving source. Find the velocity of image. Or we have a moving lens, moving source, find the velocity of image. So these concepts of relative velocity should be absolutely clear. If you are clear with these, it's a matter of few seconds to go and solve those problems. Even in JEE Advanced 2022, they asked a problem on the moving concave mirror. Concave mirror was moving with some velocity, source was moving at some velocity, and image was found to be at rest with respect to ground. The problem was to find the velocity of mirror with respect to ground. So again, all these concepts will be useful. We just put entirely based on this concept. So if these concepts are clear, just go and solve it. Few seconds, perhaps say 15-20 seconds it will take. So these concepts are extremely valid. Okay, so important. So you must know them thoroughly. Fine. Now I rub this. Okay. Now fifth example is this. Fifth example is this. P1 is here, P2 is here. P2 is moving at say 4 meter per second with respect to ground towards left. and P1 is moving leftward at 10 meter per second with respect to ground towards left. Now we have to know Vp2 P1G, magnitude and direction. So I write down the equation again. Vp2 P1 is nothing but V2 minus V1. That is same as V2 plus minus V1. Fine. Now V2 is how much? 4 left. This is 4 left. Now V1 is 10 left. So minus V1 will be 10 right. If we add these two vectors, we get Vp2 P1G. Vp2 P1 is the resultant of these two vectors. Now they have the opposite direction. So Vp2 P1 magnitude will be just equal to 10 minus 4, 6 meter per second. And its direction will be same as that of these two vectors which has the larger magnitude. This is more, 10 is more than 4. And this is rightward direction. So Vp2 P1 also be in rightward direction. So this is the fifth answer. So this is the method. Not unnecessarily writing minus, minus, 2 minuses. No, not those things. Not that. That's not the way. You just calculate it mentally in your mind and then convert it to whatever coordinate system it is given. But don't do that 10 minus 4, 10 minus 2. No, that's not the way. You get stuck up unnecessarily. You waste your time. Okay. Now I'll take the sixth example. Okay. I take up the sixth example. Sixth example is this. P1 is moving leftward, say at 8 meter per second with respect to ground, and P2 moves, say, rightward at, say, 10 meter per second with respect to ground. Now again we have to find the velocity of P2 with respect to P1 in ground frame. Okay. So we have to find Vp2 P1 G. That is nothing but V2 minus V1. That is nothing but V2 plus minus V1. Fine. V2 plus kya? Minus V1. Alright. Now V2 is nothing but 10 right. So this is nothing but 10 right. 10 meter per second right. I simply say 10 right. I don't say meter per second. That I omit. I write it at the end. Okay. And V1 is 8 left. So minus V1 will be 8 right. Now you have to add these two vectors. Resultant of these two vectors is Vp2 P1G. Now 10 right and 8 right. They have the same direction. So magnitude of Vp2 P1G will be the sum of magnitudes of these two vectors. 10 plus 8. That will be equal to 18 meter per second. And both have the rightward direction. This also will have the rightward direction. See like this. So Vp2 P1G will be equal to 18 meter per second in rightward direction. That is therefore the required answer. I hope it is perfectly clear to you. So this is the way of handling the relative velocity problems for the case in phase 1. And velocities are either parallel or anti-parallel. This is the best way. Okay. Now I rub this also. Okay. Now I take one more example on phase 1. I take up one more example on phase 1. Alright. One more example on phase 1 I take up. Another example is this. P1 and P2 are two moving points. No, P1 and P2 are, no, I don't think that will be proper. That will not be a proper thing. No, that's all. This I discussed in phase 2. I discussed this in phase 2, not in phase 1 itself. Okay. I discussed this problem in phase 2, not in phase 1. Fine. So this I discussed problem on phase 1. Fine. So this was the 18th session on relative velocity. I have taken up these basic fundamental problems to calculate the relative velocity when between 2 points when they are moving either in the same direction or opposite directions. So this method I have fully discussed. Okay. So you go through it all right. If you go through it properly, understand it, this will be very helpful to you while solving advanced problems, especially JEE advanced problems. It will be greatly helpful. Okay. These basic concepts should be absolutely clear. Otherwise, if you get stuck in mathematics, your time will be gone in the paper itself. Okay. So now we close this. Okay. So in 19th session, we continue on phase 2 of relative velocity. In that case, we find V2G, Vp2, P1G when velocities of P1 and P2 are neither parallel nor anti-parallel. They make some arbitrary angles. Okay. Then we discuss that in phase 2. Fine. Now I close this.